For centuries, humanity believed the night sky was a silent collection of stars. Then we discovered galaxies. Not dozens, not hundreds, but hundreds of billions of them, each one containing billions, or even trillions of stars. And just when it seemed impossible for the universe to become any more mysterious, astronomers looked even farther into the darkness. What they found has forced scientists to ask questions that few expected. Questions about how galaxies formed, how quickly the universe evolved, and whether our understanding of the early cosmos is still incomplete. Today, the most powerful telescopes on Earth and in space are detecting galaxies so incredibly distant that their light began its journey toward us more than 13 billion years ago. Think about that for a moment. The light entering our telescopes tonight left those galaxies long before the Earth existed in its current form. Long before our sun was surrounded by fully formed planets. We're not simply looking across space. We're looking back through time. Every additional billion light years is another chapter in the history of the universe. It's the closest thing humanity has ever built to a time machine. But here's where the mystery begins. According to the standard model of cosmology, the first galaxies should have been relatively small and chaotic. After the Big Bang, the universe needed time. Time for gravity to pull matter together. Time for stars to form. Time for galaxies to slowly grow through countless mergers over billions of years. That picture seemed to make perfect sense, until astronomers started seeing something completely unexpected. Some of the earliest galaxies appear far too large, far too bright, and far too mature. It's as if someone opened a history book to the first page, only to find massive modern cities already standing. Something doesn't fit. One of the biggest breakthroughs came with the launch of the James Webb Space Telescope. Designed to observe the oldest light in the universe, Webb peers through vast clouds of cosmic dust and detects faint infrared light that has been stretched by the expansion of space itself. Scientists expected Webb to discover ancient galaxies. It certainly did, but many of those galaxies were unlike anything researchers had predicted. Some appeared to contain enormous numbers of stars despite existing when the universe was only a few 100 million years old. Others seemed surprisingly organized. Instead of chaotic collections of newly formed stars, they looked remarkably well-developed. Almost too developed. Naturally, astronomers questioned the data. Were the distances correct? Could these galaxies actually be much closer? Had the telescope made an error? The observations were checked again and again. As more data arrived, the mystery only deepened. While some early estimates have since been refined, the overall picture remains fascinating. The early universe appears to have produced galaxies more efficiently than many scientists had expected. That doesn't necessarily mean our theories are wrong, but it does suggest they may be incomplete. Perhaps stars formed faster. Perhaps galaxies merged more rapidly. Or perhaps there are processes in the early universe that we still don't fully understand. And that's what makes this discovery so exciting. Science advances not when every prediction is confirmed, but when nature surprises us. The universe doesn't have to follow our expectations. It simply follows its own laws. Every unexpected observation becomes an opportunity to learn something new. But distant galaxies aren't only challenging our ideas about cosmic evolution. They're also revealing something even more astonishing. Some of these galaxies are producing stars at extraordinary rates. Imagine an entire galaxy creating hundreds or even thousands of new stars every single year. For comparison, the Milky Way forms only about 1 or 2 new stars annually. These ancient galaxies were true stellar factories, brilliant islands of light blazing across the young universe. How they managed to build so many stars so quickly remains one of astronomy's biggest puzzles. And, perhaps, it's only the beginning, because every time astronomers push their telescopes deeper into the cosmos, they discover another galaxy, another mystery, and another reason to believe that the early universe was far stranger than anyone had imagined. But the deeper astronomers look into the universe, the stranger these galaxies become. One of the greatest challenges in astronomy is understanding how the first stars appeared. After the Big Bang, the universe was a very different place. There were no planets, no galaxies, no black holes as we know them. Only a hot sea of hydrogen, helium, and tiny fluctuations in matter that gravity would slowly shape over millions of years. According to our best models, the first stars should have taken time to form. Those stars would then create heavier elements, explode as supernovae, and eventually give birth to the first galaxies. It was expected to be a gradual process. Instead, some of the galaxies discovered by modern telescopes seem to suggest that the early universe was evolving at an astonishing speed. It's as though nature wasted no time. Within a relatively short cosmic period, enormous collections of stars had already begun lighting up the darkness. That raises an extraordinary question. Did galaxies simply grow much faster than we expected? Or are we missing an important piece of the puzzle? One possibility is that the first stars were very different from the ones we see today. Astronomers believe the earliest generation of stars, known as population 3 stars, may have been absolutely enormous. Some could have been hundreds of times more massive than our Sun. These giant stars would have burned incredibly brightly, but only for a few million years before exploding. Their violent deaths would have enriched the surrounding space with heavier elements, allowing new generations of stars to form much more quickly. The problem is, no one has ever observed one directly. They remain one of astronomy's greatest missing pieces. Scientists know they almost certainly existed, but because they lived such short lives so long ago, finding evidence of them is extremely difficult. James Webb may eventually provide the first clues. And if it does, it could completely change our understanding of the universe's earliest years. Then there's another mystery: the black holes. Almost every large galaxy contains a supermassive black hole at its center. Even our own Milky Way is home to one. But some of the most distant galaxies appear to contain black holes that had already grown to enormous sizes when the universe was still remarkably young. How is that possible? Normally, black holes grow by consuming gas, dust, and occasionally stars. That process takes time. A lot of time. Yet somehow, these ancient black holes became cosmic giants far earlier than many scientists believed was possible. Some researchers think they may have formed from unusually massive clouds of gas that collapsed directly into black holes. Others suggest they experienced periods of extremely rapid growth. For now, no explanation has solved every question. And that's exactly why astronomers are so fascinated. Every unexpected observation is another clue, another piece of a puzzle that's still incomplete. Perhaps the most breathtaking realization is this: when we observe these distant galaxies, we're seeing ancestors. The galaxies themselves have changed dramatically over billions of years. Some have merged with others. Some no longer exist. Others have grown into enormous structures far larger than they appeared when their light first began its journey toward Earth. In a way, the universe is showing us its family album. We're watching galaxies during their childhood, long before they became the magnificent spirals and giant ellipticals we see in the nearby universe today. And perhaps somewhere among these ancient systems lies the very first galaxy that ever formed. The moment when darkness gave way to light, the beginning of the cosmic structures that would eventually lead to stars, planets, and one small world called Earth. The closer astronomers come to finding that first generation of galaxies, the closer we come to answering one of humanity's oldest questions: how did everything begin? And with every new observation, that answer seems both closer and more mysterious than ever. And perhaps that's the most remarkable part of this story. The farther we look into the universe, the more we realize how little we truly know. For centuries, people believed the stars were fixed points of light. Then we discovered galaxies. Later, we learned that the universe is expanding. After that, we found that most galaxies contain supermassive black holes. And now, the most distant galaxies ever observed are forcing scientists to rethink how quickly the cosmos evolved after the Big Bang. That doesn't mean everything we know is wrong. Far from it. The foundations of modern cosmology remain incredibly successful at explaining the universe on the largest scales. But history has shown that every great scientific theory can be refined when new evidence appears. That's exactly what these distant galaxies are offering us. Not proof that physics is broken, but an opportunity to understand the universe more deeply than ever before. Every image captured by the James Webb Space Telescope is packed with thousands of galaxies. Many are so distant that each tiny speck of light represents an entire civilization's worth of stars. Billions of suns, invisible to the naked eye, hidden inside what looks like nothing more than a faint dot. It's almost impossible to comprehend. If you held a grain of sand at arm's length against the night sky, the tiny patch of space behind it could contain thousands of galaxies, each one with countless planets. Each one with its own history, perhaps even its own forms of life. The scale of the universe is so enormous that it challenges the limits of human imagination. And yet, we're beginning to map it, one observation at a time, one galaxy at a time. Future observatories will push even farther than James Webb. The next generation of telescopes will search for the very first stars. They'll investigate the earliest black holes. They may even witness galaxies forming only a short time after the Big Bang itself. Every new mission will bring humanity another step closer to understanding how everything around us came to exist. But perhaps the greatest discovery won't be one we've predicted. Again and again, astronomy has taught us the same lesson. The universe loves surprises. No one predicted pulsars. No one expected planets around other stars to be so common. No one imagined black holes would eventually be photographed. And few expected the earliest galaxies to appear as fascinating as the ones we're discovering today. That's why every new image matters. Because somewhere in the ancient light still crossing the universe, there may already be evidence of a phenomenon we've never imagined. Something that will reshape astronomy once again. Something that future generations will read about in textbooks as the moment everything changed. Maybe that's the true beauty of science. Not having every answer, but never stopping the search. Every mystery solved reveals another waiting just beyond it. Every horizon reached uncovers another horizon farther away. The universe doesn't become smaller as we learn more. It becomes infinitely richer. So the next time you look up at the night sky, remember that some of the faintest points of light are more than 13 billion years old. Their journey began before our sun existed, before Earth formed, before life appeared anywhere in our solar system, and after traveling across almost the entire history of the universe, that ancient light has finally reached us, carrying a message from the dawn of time. If you enjoyed this video, don't forget to leave a like, subscribe to the channel, and turn on notifications so you never miss our next journey through the greatest mysteries of space. Because somewhere beyond the most distant galaxy we've ever discovered, another one is waiting, even older, even farther away. And it may hold the answer to one of the greatest mysteries humanity has ever asked. How did the universe truly begin?